Jimmy, you genius.
I found my problem.
Ah! So I've printed out 6 or 7 pages from the electrical starting system troubleshooting from the manual for an 87 YFM 350 FWT. We got a couple of parts we're looking for. This has a coupler that would go from the breathing hose here to the box, so you don't have to use this radiator hose. And of course this is a breather. We're taking this out right now. That's a breather hose, should be open. Let's put this where we don't run over it. So I've done a lot of kind of guessing, getting this harness back to OEM. We're going to plug our stator back in here. But what we're going to do today is we're actually going to just go along. We're going to follow the manual troubleshooting process for the ignition system and see if we can pinpoint. There's 7 or 8 steps in the manual. And I got a digital copy of the manual as well. You can get a digital copy for 10 bucks or so online, as opposed to a paper Haynes manual, which will run you 40 or so. But that should walk us through everything related to the starting system. And then we'll keep going from there as needed. So, first page is just where everything is. This is section 7.6 in the manual. First thing I had talked about this before, this is testing for motor crank right at the starter, so might be difficult to see, but really what we're going to do, either from a jump box to the starter, or in this case we have a good battery, we're going to go positive. I'm going to grab some jumper cables from the positive on the battery to the positive on the starter, and then we're going to go negative and ground that out. Negative on the starter, we should hear a crank. So let me get some bigger jumper cables than my testing cables. And this, actually that's step 2. Step 1, battery condition. Check your battery, make sure it's holding the charge, all that. Done that, and we're about to find out when we put it to the starter. And our next test is going to be testing starter and the starter relay. Let's start there. It's my jump set for my truck. Make sure I don't ground this out to the chassis while I'm testing. Come around to this side. A little tough, but let's get my positive. Get my positive onto start. Oh. Ready? Here we go. So that cranks the motor. There is oil in here. I did put oil back in. I'm just going to touch my positive now. Okay, so we have a good starter. Negative to the battery because the starter is grounded to the chassis, so just touching to the bolt, the positive on this one, we have an answer. So we have a couple of answers. We know the battery's good, maybe a little weak, but it's a good battery. We know the starter is good. So let's move on to the starter relay, also known as the solenoid. And what it is advising us of here, if the starter motor is operated, yes, go to the next step. Disconnect the blue, white, red, white. Yeah. Go battery positive to the red white. And this is a little tough. These alligator clips are great if you can get into the harness or the plug. If you can't, I actually have sections. I use Romex. I think it's 12. Yeah, Romex 12.2 can press down in. So let me grab that. There we go. This is 12.2. A little easier here on these Yamaha connectors because we can literally press this in. Voila. And we'll press this one into the other side. So this gives us a little better opportunity here. Now I can clamp to my plus. There we go. And so we're going to go look at my diagram. Red, white to the positive. We have that. The blue, white to ground. In theory, when we touch this to ground or to the battery, starter should operate. There we go, starter operated. So we know if we have signal through the solenoid, actually it doesn't even answer that. That's just another test for the starter motor. All right, moving on. 2 tests for the starter. Number 3, starting circuit cutoff relay. We're looking for the relay. That's going to be on the back. Yellow, black. Let's see, I got a yellow, black. Red, white, blue, white. Okay. This is going to be the starting circuit relay. We're going to test to see if this is good. Let's undo our setup here. Pull my wires out. We'll put this all back in. Here we go, the relay. 29U-92 ACA 1211-9. So, looking at my map, I'm going to have a positive go to what would be my red-white stripe, which is my bottom left, to the battery, and we're going to go yellow, black stripe. Yep, which is going to be my top right. Yes, it is. Oop, hold up on that. Yes, top right. To the negative on the battery. So relay switch is really just an electrical switch. And the idea being when power flows to it, it closes the switch. So we have power hooked up. So now we're going to put our voltmeter on here, and we're going to set to ohms, and we're going to check for continuity. With the battery hooked up, this switch should, this solenoid should be open. Ultimately, when I hook up, I should hear a click. So good condition battery connected should have continuity. Set this down. I'm going to go for my ohms setting, my lowest setting on here, 200 ohms. And open line, you know, as if it's a broken wire. If I touch these, it should act as one wire. Continuity should be just about 0, you know, 0.3, 0.2. Okay. So here we go. Test the solenoid. See if I can hold this probe without shorting the heck out of everything. I get open line. Double checking myself here. Positive, bottom left corner, red white, yes. Negative from the battery going to the yellow black. Upper right. Oh, I did a poor test here. I gotta go red white, which I have, but my negative goes to the yellow black. So if I touch here, I should hear a click. And I should have continuity. I have really high. I have 77 ohms of resistance, not 0, and I have no click. One thing the manual doesn't say is what I should expect for continuity resistance. It just says continuity. Closer to 0, the better quality the continuity is. Now we're going to the neutral relay. Neutral relay, this other one up here, this is the blue plug. This relay actually looks a little beat. There's no, yeah, part of the clip is snapped off. These things keep blowing away on me, so watch this. Yeah. Jimmy, you genius. Oh. Switch, reverse switch conductor. Alright, let's see. So we're looking for a green yellow reverse switch lead. It's down here on the engine, and we want to put the positive of our pocket tester voltmeter into that green yellow lead and then ground it to the engine and move the selector lever over my left shoulder here, forward, reverse, and check for continuity. So if it's in forward, we should have continuity. If it's in reverse, we shouldn't have continuity. From the reverse switch, we are clamped on. Going to my positive and the negative. Still going with the same plan where I'm going to ground it out directly to the negative. Okay. So here we are. We're in forward, 40 ohms. Same thing, 40 ohms in low and reverse. Let's get this to bump in. There it goes. No change at all. No change in continuity. Should have had no continuity in reverse. Now one thing I have with other Yamahas I've worked on, the only way to get in reverse is if you're in first gear. I'm in neutral. Let's make sure, I haven't seen this one run. There's a first gear shift. This is a little tough because even with it clicking into that first gear there, I can roll it in forward and reverse on the tires. Makes me think there may be something else blown up in here. We're going to move on from this test. We're going to call this one inconclusive, is I guess where we're at. Alright, let's move on to the neutral switch conductor test. That's this guy, sky blue. Disconnect from the harness. There we go. And which side are we going to test on here? Neutral switch lead. Here's the lead. That's the harness side. This is the lead side. It's going to be the positive side. So here we go. And the negative back to the motor as we have been doing. Back to the motor ground. Pretty clean resistance on that one, 0.1. So shift gears, check back. So in neutral should have continuity. We're in neutral. I mean, we're less than 1. We're at 0.9. Now if I go into gear, open line. Neutral looks good. And I get back into neutral, 0.1. This switch is pretty conclusive. Alright, we're going to move on to test 7. Main switch. Main switch, that's the key system. Engine stop, rear brake, main switch conductivity test. In step 7 here, there's 3 of them. Checking the engine stop button for continuity, the rear brake for continuity when that's depressed. And that would come out of the signal system, which I didn't print out, but we can test those for continuity. So here we go. Start with the brake system here. That is this guy. We've talked about this one being disconnected. We want to know if this is good, so we're going to stick our positive negative probes right in here and give it a test. Alright, so right now without the brake lever depressed, this is what we should see, open line. If I crank down on this, I should get resistance. Look at that, nothing. So we have a bad brake switch. Ultimately, that's not the end of the scenario, because we've just joined those back in here. I've done this move right here on many ATVs to bypass faulty switch. Let's test our key switch. This is a new key switch. I didn't print out the signal part of this. Let's see here. We're just going to probe and find out where our continuity is. Key is in the on position. Starting with my brown wire. Goes my instructions again. Brown wire, brown to black, nothing. That was black, white stripe, to black, nothing, to red, there we go. Continuity, brown to red, key in the on position, we have continuity. Let's try anything else. Let's go red to black, white stripe, and here again just reversed continuity. How about among our black stripe? No. Black to brown, no. Black to red, continuity. All right, so a couple of quick tests. Our black to red has continuity, our red to brown has continuity. Let me grab the original switch. The original switch, I had tested this earlier in the week, but let's go ahead and test again here. So we just said on the new switch, in the key in the on position, we have continuity on the red to black. So here we go, red to black. And I don't know if the key is on yet, so we have no continuity. And red to brown, no continuity. Key to the next position. There it is, next position. And we'll start with our brown to red. No continuity. And we were doing our red to black. No continuity. So we can't get continuity out of this original key switch any way we try and test. So we did have a bad key switch. We've replaced this, so that's one more piece in this puzzle. Hopefully that's a good electrical walkthrough on here and how to test it. I've done some seat of the pants testing. I brought the harness back to OEM, but sitting down with the manual, a voltmeter, a couple of these little alligator clips, also pretty helpful. But if you're trying to get into, depending on what you're trying to get into for connectors, sometimes I use just some 12-2 for probing. Didn't get all the way there today. Didn't get all the way there. But we have more targets. So let's answer those questions. Get this to actually all test through in a positive fashion. No fails. Really, this should get us down successfully. When I turn on the key, I should get crank. This is the starting system. I should have crank when I hit the button. And I should hear that relay click, and we're good. After that, we'll move through troubleshooting the actual ignition system, which is troubleshooting spark. So one more step at a time. All right, guys, long day, beautiful day. Been kind of back and forth through the manuals, double checking. I found my problem. This guy down here. This guy, this is a bad harness.
intermittent. There's a good fuse in here, but test this for continuity. This is intermittent. So I've wiggled it just right so I can come turn my key on, or excuse me, turn my handlebar switch on, turn my key on. There we go. There goes my oil temp light. There's my neutral light. And if I hit the button, there we go. I have intermittent spark, so we're gonna have to look at this coil. But if I go down here and I finish plugging this connector together, lost my lights. So look at that. I don't know if you can hear the click, but let's get it. Come on now. Oop, oop, oop. Almost. Almost. Oh, oh, oh. Yeah. So that's it. We did. We made progress. So we'll be able to get a reliable electrical system going here. And we'll work through consistent spark. And then we're on to the next couple of steps here. I hadn't mentioned before, but this is another gift ATV. This is for someone special. This is for my mom. She has 100 acres that she recently had logged and asked me to see if I could find an ATV she could use for hauling some wood out. She's got a cart that goes behind it. So that's the idea for this blown up one. And having watched the first couple of episodes in the series, she knows now, so she's watching along to see if I can actually bring this thing back to life for her. So big day today. Figured out electrical challenges and maybe a few more, but I think we're going to be over the hump on electrical. We'll see where the rest of this has got to go.